Continuing with the next speaker, we have Matt Howard here. He is from Chia Network, which is the company building the Chia blockchain. And he started there in 2019, and until then, so we talked yesterday, and he said it was like the 12th employee who actually started at that startup, and until now it has grown up to over 80 people working there and working at building this blockchain. And so Matt is one of the main smart coin developers, or smart contract, how you would say smart contract in other ecosystems. In Chia we talk about smart coins, but it's the same idea, programming things on chain, and he's one of the people that is very knowledgeable in this field. It's a very special kind of technology to new things to figure out, and he will talk to us about how NFTs are built on Chia and why they are built the way they are, and I'm looking forward to it. So, warm welcome to Matt Howard.
All right, hello. That was more of an intro than I was expecting. So, Chia have just launched NFTs, and I find that after you've made something is a good time to look back at it. So that's what I'm going to do. This is kind of a review of the design process, the different designs we had, and why we took the decisions that we made. Because I wasn't expecting an intro, I introduced myself. There's a picture of me and my cat, Stephen. I had coronavirus when I had that photo, and that's why I look so gaunt and sweaty, but I still use it on my LinkedIn. So yeah, I joined in 2019, and back then there wasn't the Chia-Lisp language, there was just the low-level language, which is actually what runs on the chain. So I learned that, and then eventually Chia-Lisp after that existed, and I've been involved in many Chia projects, some of which even released, and including those is the fungible and the non-fungible tokens. So let's talk about some non-fungible tokens, NFTs. What are they? Well, they are tokens that can't be divided or funged. I like to think of them as a tool for representing digital goods on the blockchain. And I'm going to keep the definition of digital goods fairly ambiguous there. You can imagine whatever digital good you like. Ownability is the name of the game here, and the thing is, when it comes to digital goods, what does owning a digital good actually mean? And this is not a trivial question, but I put some words down on the slides that I think would be good goals for something that you own. So the first word is collectible, which you might think sounds like a synonym of ownable, but it just kind of encompasses the belongs to your name sort of thing. The next one is resellable. So already maybe you can think of some digital goods you own that you can't resell. But for NFTs, that is something we desire. We desire resellability. We want security, of course, because although you can own something and have it stolen from you, you won't be very happy if that happens. We want it to be uncensorable, because on blockchain applications, we all like not being censored. If you pay the fee, then no one can tell you no. And to get to uncensorability, it's good to be decentralized. This means not having points of authority in your system. And quickly, I would like to include some points about what NFTs are not, because there are a lot of incorrect ideas maybe floating around. NFTs do not offer digital rights management. They do not offer copy protection or access protection. You can, in fact, right-click the JPEG. NFTs are not a hosting service. Although you could put your NFT onto the blockchain in its entirety, I wouldn't recommend it, because it's very expensive and you don't need to do that. NFTs are not the only way to pay an artist. You can go onto Twitter and give people money. You can just do that. You can get commissions and buy merchandise, and you can support artists in a wide variety of ways. NFTs are not the only way to buy and sell digital goods. We have the iTunes store. We have the Amazon Kindle store. We have the Steam store. There are other ways to sell digital goods. So NFTs are just one way of doing some of these things. What do we want Chia's NFTs to have? When setting out to design something, it's nice to have goals and ambitions. So, At the top of the list, I've put design for the future, not for the present. Because the future is coming eventually. And the present could be better. So unfortunately, my clairvoyance does not extend beyond the future is coming. So we've got to keep it upgradable and other things that I'll talk about later. We want a strong sense of identity because with NFTs, the identity kind of matters, right? If you're collecting these things, you want to have a sense of you. If you're a big collector, maybe having your own personal gallery, you're going to want an identity associated with that. If you're a small fella, maybe just owning 1 or 2 NFTs, then you might want that to be attached to your Twitter profile. And that's another way that you're representing your identity. And for creators as well, the sense of identity is important because in the art world, the artist actually matters. So those are some things. We also want strong capabilities around selling because that ties in with the values I talked about on the previous slide. We want on-chain royalties for creators, if the creator so desires the royalties. Because royalties are a very good use case of NFTs because it's the sort of thing that smart contracts are good at enforcing, and creators like getting money. We want clarity around the rights an NFT gives you. Early on with NFTs, there was this problem where you weren't actually sure what you were buying. If you bought an original character with a funny hat, you might think that you owned that character and could then put him in a film that you were producing. Or maybe you thought that you could own that art piece and have the rights to reproduce it and sell copies. And we just want some clarity. What are you buying and what rights does it give you? The next 3 are a little bit more technical, more of an engineering perspective. We want updatable metadata. NFTs contain links to the digital good. And we want to be able to make sure that it lives forever. Servers go down and domain names fail to get renewed, and images sometimes get deleted or lost. So we would like the data to be updatable, optionally. If the data is updatable, we want to make sure that we are getting the correct data. So we want to be able to verify an NFT's contents. And at the very bottom here, I've put decentralized trading via offers. And you probably don't know what that means because I've not introduced it yet. So I'll introduce it later and then you'll know what that means. So we go deeper into engineering. Chia's coin model. There are 2 ways of doing a blockchain, roughly. You have the UTXO model that Bitcoin uses, or the global state address model that Ethereum uses. Chia chooses to go with the coin model, and coins are UTXOs. We call them coins because they are a slightly different model. We have only 3 things inside of a coin. The parent coin ID, the hash of a program we call the puzzle, and an amount of Chia that it represents. In order to spend a coin, you must reveal the puzzle, the program, and then run it. If running of this program is successful, that coin is destroyed and spent. The running of the program determines whether that coin will, in fact, make more coins or not. And that is the life cycle of a coin in the Coinset model. For more information about this, visit chialisp.com. It's a website I'm going to plug a few times during my talk. Let's go more into what happens when you run the puzzle. Like a lot of programs, it has an input and some output. We call the input a solution, and it's just a list of values, and those values depend on what the program is. The output is in a standardized format called a list of conditions, and the conditions take the form of, this transaction is only true if some statement. So for example, this transaction is only true if this coin is older than 2 months old. This transaction is only true if this coin has an amount of 350. So combined with running inside of the program, because a program can also decide this is not a valid transaction, it allows you to rule out a lot of behaviors. And we also have another type of condition that says, if this transaction is valid up until this point, then do something. If this transaction is valid up until this point, then create a new coin with this puzzle hash and this amount. If this transaction is valid up until this point, then make a coin announcement with this message. The most important condition in the conditions language relates to signatures, because information is malleable. When you send off a transaction to the network, you have to make sure that it's secured. Otherwise, people can change your things and then give themselves money instead of you giving yourself money, and that is not good. So we have a condition that says this transaction is only valid if this value is signed by the owner's key. And so you want your coin puzzles to include that, because then it is owned by your key and secure. Jolly good. So now let's move into the standard puzzle. When you send a coin in Chia to the standard address, that is actually a program that is owned by your public key. We do two fancy tricks in the standard puzzle. One is called taproot and one is called graphroot. And I'm not going to talk about taproot because it's not relevant. But graphroot is just a nice way of talking about delegated puzzles. So here we have actual real Chia code that runs on the blockchain. So ignore the fact that there are two public keys, because that's taproot shenanigans. We have, in all capitals, something that is curried in. This is effectively a constant that exists on the chain. It's your public key. And then the things that are in lowercase are the solution. So in the solution, you would pass in the delegated puzzle and the solution, and optionally the original public key, but we're not talking about that. So what do you do with these? Well, here we have some code that you might not understand it. It's okay. I'm going to talk you through it. A, that means run. Run the delegated puzzle with the solution for the delegated puzzle that you've passed in. This means that you've effectively offset the functionality. You've said, I'll decide what the program inside the coin is later. And then you secure it by saying add C, cons, which means add to the list of conditions a list of agsig, public key, hash of the puzzle. So the only thing that you secure is the puzzle. You could make the puzzle constant and output conditions, or you can further delegate to the solution in that. Things get recursive pretty fast here. Don't worry if you got lost. Now let's go up a level to CATS. CATS was the first token we released, the fungible tokens. It stands for Chia Asset Token. It's very cute. And we designed this with the idea that ChiaLisp is really good at having these recursive layers going down. And we had a cat layer. And the cat layer is in charge of enforcing catness. That is, all the rules related to being a cat are enforced there. And it doesn't care what happens underneath as long as it does its job. This comes to one of the advantages of Chia's coin model, is the layering of puzzles is very good for financial use cases as well. You can do, I don't care what happens beneath me as long as you aren't spending more than 200 Chia this month. I don't care what happens underneath me as long as you are only paying out to pre-approved people, so on, and you can keep going down. But typically at the bottom of you will get the inner puzzle. This is normally represented by a standard puzzle, which I showed on screen briefly, but you can put smart things in there too if you desire. Code inside code, programs inside programs. The nice thing about doing the cat layer wrapping a standard puzzle is it makes token discovery pretty trivial. We use the hinting system on our blockchain to say, oi, listen, and then the wallet knows what its own standard puzzle is and can infer what the puzzle reveal of the cat type is, and then bada bing, bada boom. But I won't talk about the wallet much more. Offers. So I talked about delegating behavior and leaving things unsigned. One advantage to this is that we can leave things malleable. What would a behavior be like if we didn't care? So in a transaction, if you're transacting in the world, you really only care about getting what you want, and it's up to the other people to claim the thing. So you could make a malleable transaction where you assert a truth. This transaction is only valid if someone pays me 2 of this stable coin. And then you would also, in the transaction, say, I am spending 5 Chia to unsigned address. And what this means is someone can take that, and it's not valid on its own, but as long as they give you that 2 stablecoin cat, that becomes valid, and they can securely take the 5 extra that are being offered. This means that you can do decentralized finance. Very cool. Decentralized trading without markets. And this object, this malleable transaction that people claim and finish, is actually just a few kilobytes. And you can send it around on messaging services, forums, any other website that you'd like to think of. And it's free to create these offers because you're not hitting the chain until it's accepted. This is literally just a file that people are looking at. And you can imagine all of the advantages of being peer-to-peer and not going through markets. Here is somebody making an offer on Twitter. This is very cool. I'm going to say very cool a lot because I genuinely do think this is very cool. All right, next work. Singletons. So the singletons are kind of a vast topic, and I'm not going to get into how they work. They just work. You can look into that at cheerlisp.com. But they are indivisible, unforgeable. They have a unique ID, and you can track state across time. We first used them for our pooling protocol, and you can put smart things beneath the singleton layer, and that allows you to do leasing power, which is how the pooling works. I have talked about singletons previously here in this video on cheerlisp.com, but for now, just know that it's a layer that enforces these things. You might think that those things are a lot of the legwork towards NFT, and you'd be right, but we'll get to that. Another piece of work that we did previously was distributed identities. This is the sense of an identity that you can self-publish on the chain and will interact natively with smart applications. So the thing about a lot of accounts that you might have online with a Facebook account or a Google account, they're kind of permissioned, which we don't want. So we want something where you can publish it yourself and then use that to interact, and that is a DID. We are going to be doing more DID work in the future, so we've left them upgradable. But basically, this is a singleton that represents you, and you can put as much information about yourself, and any credentials from external parties can be attached to it. They're cool things. I like them. So that brings us to all of the tools that were available to Chia while we started designing NFTs. And we went through 3 stages of development, and I'm going to explain all of the designs and kind of where we were at mentally doing them. So the first approach was the cat-like design, where it would be a layer, an inner puzzle. The singleton layer enforces the uniqueness, the NFT layer would hold the NFT's information, and then the inner puzzle would be in charge of control. This was intuitive to understand and similar to previous applications we've made, but there was no royalty system and a weak sense of identity. It supported offer files, though, and you could put smart things in the bottom, but those cons were too strong. We could design better. This was the architecture diagram, the 3 different types of green there, singleton layer, NFT layer, inner puzzle. The second design we came up with was much more strongly tied to distributed identities. This was a very tempting idea that we were enamored with for a while, because there's a strong advantage to tying to DIDs. You no longer put keys in the NFT, and there's this implicit connection. Where the DID goes, the NFTs follow without even moving. So the NFT layer in this version was a rigid shell that just supported a few different spend types. And anytime you tried to spend it, it would basically say, this spend is only valid if the DID says so. And we had a transfer program as well, represented here by blue. The NFT layer is represented so fat because it was doing a lot of work. And you can see there's no inner puzzle because it's all in the NFT layer. And the transfer program was put there by the minter and would run every time the ownership changed. And this was allowed us to enforce royalties. The transfer program had rules around being able to add conditions and examine existing conditions, but not change the existing conditions, which meant that even a malicious minter would not be able to steal an NFT. The pros of this were the extremely strong sense of identity. It's something that was a design goal for us, and it was very appealing. Having a DID attached to online accounts was trivial, and the games that you could play by partially custodying your DID were tempting. For example, you could get onboarded on a certain marketplace, then completely withdraw your DID, and then have decentralized ownership of that. and then you could give partial spend permissions to other places to do things on your behalf. It's an interesting way of thinking about your identities and your accounts and permissions. We also had a strong royalty system tied to these identities. But there was a problem. The offer files work by giving you permission to spend a coin later if you meet some conditions. However, if you spent a DID at all, that would destroy the coin and recreate it, which meant that all of those offer files would be invalidated. There was also the problem of the overly rigid structure, which is not exactly future-proof. And there was another problem with UX in that people like receiving things to their standard address. It's right there in the front of the wallet. That is my address. Send me things here. By being owned by a DID, you had to send it to a different type of address, which was confusing for users. So we went back to the drawing board once more and came up with a modular approach. You see, while the DID design was tightly integrated, it wasn't customizable. We'd built a system on a chip when really we needed to build a gaming PC motherboard. So the good thing is that Chia is very good at puzzles within puzzles, programs within programs, code within code. So we could separate out different pieces of NFTs functionality into different modules and allow people to customize those modules to have the rule sets that they wanted. One of those modules could be related to DID ownership as well. So we'd get the advantage of tracking ownership from DIDs across time on the blockchain, but we could do it better. The best of both worlds. Hannah Montana. So remember, layers don't care what's underneath them. So strictly speaking, and in beta testing, we had something we called NFT 0, which looked like the top. Singleton layer, NFT state layer, standard puzzle that owns it. But you can expand this to have a series of modules that look like the thing on the bottom. Here's the architecture diagram for that. So you might recognize the transfer program there. There's a new thing called the metadata updater, and the ownership layer is new. So let's take a look at all of these things in a bit more detail. The state layer. This is where we stored the data related to the NFT. For example, the link to the digital good. We can extend for off-chain data as well, and we use hashes to verify that the stuff you get is correct. We also have a program in the state layer called the metadata updater, which contains the rules relating to when data can be changed, because different people might have different opinions on how flexible they want the data to be. This is the actual Chia Lisp code. Remember, the stuff that's in all capitals is curried in and a constant. So the metadata here is stored. The metadata updater is stored as a hash because it's run so infrequently, it's actually more efficient to just store the hash and reveal the code only when you run it, saving space on the chain. And then we have an opaque inner puzzle, which this layer doesn't care about. The form of metadata in Chia Lisp is in key value pairs. The keys are pick and choose, but the most common two are U for a list of URLs and H for the hash. When you retrieve something from the URL, you check it against the hash, and then you've got verification. Another important one is the metadata key, LI. This allows you to add a link to the license, and that solves that problem. The metadata updater. This is the module that controls the rules around updating the NFT's data. This is set at mint time and is a fairly powerful program. It knows what the current metadata is and is the only thing that can authorize that to change, but it can also update itself. The solution to this is generated and passed from the inner puzzle, from the state layer, and the default behavior in the NFT one that we launched has these two rules. Users can add new links to their NFTs but not remove links. And users are never allowed to touch the hash. Beneath this, we have the ownership layer, which tracks the current DID owner, a transfer program, which is similar to the DID-oriented transfer program design, but different, and then another opaque inner puzzle. Authorization can only come from the transfer program, and this transfer program is very powerful. This is put there by the minter and effectively counts as the lasting influence that the minter has over the NFT in its lifespan. It runs every time the owner is changed, and sometimes when it's not. It knows who the current owner is and can update itself, and we suggest this is where people put the royalty calculation, which is what we do as the default behavior. Only the transfer program can change who the current owner is in the ownership layer. And that actually is just the full architecture, because the standard puzzle is, we've already covered that. But the other thing is you can put smart things in the standard puzzle. Really, standard puzzle should just say inner puzzle, because you can keep going deeper and adding more layers. Programs within programs, code within code. This brings us back to offers. By putting a standard puzzle at the bottom, it allows us to do offers. The claimant simply accepts the offer as terms. In this transaction is only valid if statement, and they must also pay the royalties. But this means that you can do decentralized peer-to-peer trading of all assets. NFTs for NFTs, NFTs for cats, cats for Chia, 2 different NFTs for 4 different types of cats. Pick and mix, it's very fun. Dare I say it, very cool. And again, these are free to create, uncensorable, the whole 9 yards. So let's talk about royalties, because that's something I've kind of glossed over a little bit. But in blockchain applications, you have something called the Oracle problem, where it comes down to who do you trust to tell you things. For example, if I was building a weather insurance application, I'd need someone to tell me what the weather was, at which point BBC Weather might become a point of centralization in my system. With royalty sales, though, that's kind of a big one. Other blockchains tend to use exchanges to take the role of reporting the price of a sale. But this means that they end up as centralized authorities and might end up censoring you. If you think that's fear-mongering, it's literally not. This is an article about blacklisted NFTs, aka censored NFTs. So that's not very ownable, right? Okay. Royalties and the on-chain price history that we use. We enforce that people trading must self-report and both co-sign the listed price. This puts their identity co-signing the price. So if they're found out to be naughty boys, then tut-tut-tut. They become dishonored. In order for this to be fair, we must make sure that people are able to see what has been traded. Auditable, decentralized, uncensorable. The default behavior for royalties is to accept any type of asset, but in fact, you can limit the transfer program to only take specific types or specific assets. That's fine. There is also a further incentive for honesty because the on-chain price history. Because we've cut exchanges out, the blockchain itself becomes the on-chain price history, with parties reporting the price, and you can check in on how much price has been reported across time. This means that the value of your good is tied to the history of the price. So if you underpay, you're going to be paying fewer royalties, but you're going to be devaluing your asset in a literal sense. If you overpay and decide to wash trade to inflate your asset, then the original creator goes yippee and taxes you on that transaction. This means that the price reported trends towards the truth. And now I want to take just a second to talk about modularity, programmability, and Chia's design philosophy. Everything that I've talked about here is tweakable, or even optional. You don't have to use the code that we've written, because it wasn't cheated. We've not baked this into the consensus layer. We've used the same tools that are available to you and split it out into modules that you can pick, choose, and customize from. And that is kind of the point of what we're building here, because the future of digital goods is coming, and I don't know what it looks like. Maybe it will be a metaverse in the way that you might have seen try to be sold to you in sales pitches. But if that, whatever it is, you have a choice of whether it's going to be owned by marketplaces that act as the new gatekeepers, or multinational corporations that own the metaverse, which is ridiculous, or you can have it open source, decentralized, uncensorable, and customizable with code that you can write yourself. I think I know which one I prefer, but then again, I am employed by Chia. That was kind of something. So I thought of a fun way to end this would be I dreamed up some potential NFT variants that you could program yourself if you'd like. The first one is number go up NFT, where the transfer program has rules relating to never letting the price go down. You literally cannot sell it for less than you bought it for. You can only ever make a profit. Genius. Second is fractionalization. The NFTs are locked up at the bottom of the stack with a puzzle that will only unlock, this transaction is only valid if, you provide a certain amount of a given cat. That cat then becomes a representation of a percentage of that NFT, and you can trade in fractions. The next up is monopoly-free parking royalties. I thought it would just be crazy if all of the royalties went into a pot and then someone gets that later if they own the NFT. I think that'd introduce some interesting trade dynamics, but I think some economic students might disagree with me. Old school DID-based NFTs. If you think that we had it right before and you don't like the module design, you can just use the modules to make the old school DIDs. You can reprogram it to have the exact same functionality where the spirit moves through many bodies. And then I have to plug some stuff. So we have a website and a blockchain, and you can mint an NFT today if you'd like. We have programming tools at cheerlisp.com. We have a lovely community on Keybase. This is the messaging app we use, and Twitter. I don't need to tell you what Twitter is. We also have our own NFT collection, Chia Friends. That NFT there is my cat, Steven, represented in front of the Spice Girls Spice World flag. I love my cat, Steven, but I don't own that NFT because it was really expensive. And that's it from me.
Thank you very much, Matt, for that very inspiring talk. Are there any questions? Yeah.
So if there's no centralized market and everything is peer-to-peer, how do you imagine trading will work? Like, because I have an offer, then I have to be lucky that the right person sees the offer?
So we already have things like there's a website called OfferBin where people will just drop their offer files and it will organize them for you. Markets become matching people with offers rather than doing the work themselves, if that makes sense. Because you can connect people through the offer files. You get centralized buckets where people will post offers, but then those offers are actually just connections between two people.
Any other questions? Something in the Slack or in the Zoom?
Thank you for this speech. What is your process of decision to select the new standards in NFTs? How do you, who decide which are the standards?
So we do have the chips, which are the Chia improvement protocols, which are open sourced and debated by the public. We have a chip for NFTs, but a lot of the initial design came from people who were experienced with Chia talking to each other.
You were mentioning the chips. Who ultimately decides on those? Is this then consensus-based, or is it you, the company?
I think it's consensus-based. I've not been looking at the chips too much myself. I can't answer that question, sorry.
So I can talk a bit about that. So I was at least being the community part in one of the chips regarding NFTs, and it was the community figuring out stuff together, discussing things, and then there might be somebody taking that decision, but it's a community-based effort. So, but I mean, nobody prevents you from doing things differently, but every time you form a standard, you have to like figure out what the consensus between people is, and then you have like the one authority that says, okay, this is now a standard that we recognize, but it's nothing that nothing prevents you from doing it differently. The governance process is a GitHub discussion, yeah. Any other questions? Yes.
Thanks for the talk. I have an organizational question. I mean, you're developing an open source protocol, and so how what's Chia's business model? How do you get paid, to be frank?
We're a networks company. We make a network. This question's kind of a little bit not relevant because this is about NFTs, but I think Chia has a Red Hat Linux model where we collaborate with other businesses who will pay to use our systems.
Okay, thanks.
On your last slide, you said things you can do today, I think. Yes, what can you do? And the first point is mint an NFT today, which got me wondering, if I wanted to do that, like if I went to the hotel room later and I took a picture, how many steps and how much time would it actually take for me to make an NFT out of a picture? What do I have to install? What do I need?
So you'd want to install the Chia application. We have a very friendly Chia application that does everything for you. And you can mint through the command line, I believe. You could even go to a marketplace and have them mint it for you if you don't want to install anything. But yeah, install the Chia application and follow our documentation on using the command line.
So is that minutes? Is it hours? Is it days?
The thing is, you'd have to sync to the network. But actually, we've got a fast sync. Minutes, yeah.
Oh, wow. That's impressive.
Is uncensorability not potentially dangerous if someone uploads illegal NFTs?
People can do that if they want, but then they'd have done something illegal.
And that's not your responsibility then, and the network?
I mean, people can put illegal things in lots of places.
Yeah,
right?
but companies have responsibility there to remove those things.
Unfortunately, the blockchain is run by 1 million decentralized nodes. Chia, the company, has no control over what farmers in Serbia running on their computer do.
Okay.
All right. There's time for one more question if there is one. If not, I thank Matt again for coming to us here in Munich from London and giving that talk. I enjoyed it very much. And you can clap again and I can... and I give you a little present for that.